repeat myself again. Supplementary exams, they don't necessarily change the format of the paper. It's going to be similar, but they'll change the figures. So if you know how to solve, then it will be easy for you. That's how it is. Okay, so let's keep on solving. Keep on solving this paper, the paper you wrote. Do it 3 times. 3 times. 1120 question 2. I don't know if it's question 2, the one for SADS. When I was simplifying, I forgot to put, it was 3 minus 2 root of 3, 2 root of 3, like this. I forgot to include the 2 in the next step. That was an error. Take note on that. Okay, so let's start. So the first question is, solve for x in the logarithmic equation. Solve for x in the logarithmic equation. Genuinely speaking, guys, what is happening here is this. Sometimes you might think this question is hard, but it's not hard. Looking at it, you might be thinking to say you can't solve it, but it's simple. Okay, so we have log x to the power 8 is equal to log x raised to the power 4. This 4 is affecting the log and the x, so it's different from this. This is just log x to the power 8, so it's different from that one. The only thing I'm going to do here is I'm going to shift this to the left hand side, to the right hand side. So here will remain with 0 is equal to log of x to the power 4 minus log x to the power 8, like that. This is the same as I can rewrite this and say it is log x raised to the power 4 minus log x to the power 8, like that, is equal to 0. At this point I have got log, this is everything is raised to the power 4, this is just raised to the power 1, everything here. So I can factor out log x. Is that okay? But here, guys, if I factor out log x, this is just x inside, but here we have got x to the power 4. If I factor out log x, then that is wrong. The best thing I can do, the property of log allows me to shift this, the power, to be in front. But I can't shift this to be in front because that power is for both x and log. You can only shift that to be in front if it is the power of x only. Does that make sense? If you have got question, ask.
Sir, I'm kindly asking if you may start again from 0 is equal to log 4.
If I may start again from where?
0 is equal to log 4. I missed it there.
From here?
Yes, please.
No, like I was just rewriting this. This is that. That 0 is the 0 which you have here. I didn't do anything. This and that, they are the same. I've just started writing this, then 0, put it there. Have you seen?
Yes, sir.
Yes. So what I'm going to do is I'm saying if I've got log x to the power 2, the property of log allows us to shift this to be in front. So this will be the same as 2 log x. But I can't shift 4 because 4 is not the power of x. It's the power of everything on log x. You understand, right? So what I'm going to do is I'm going to say this is log x to the power 4 minus, I'll shift 8 to be in front, 8 log x, like that. Now I can see that this is the same as you have got x to the power 4 minus 8x, like that. The best thing I can do, I can factor out x. Then it will be x to the power 3 minus 8, not so, is equal to 0. It's the same thing. So here I'm going to factor out log x. I'll say log x, okay, will be open brackets, meaning here I've remained with log x to the power 3 minus 8 is equal to 0. Any question there?
So why and it's x to the power 3?
Because I have got log outside. This times that is again log to the power 4. This times 8 is 8 log x. I've factored out a log x. You have seen it? Hmm?
Yes, sir.
So this is the same what we have here. Hmm?
Can you repeat?
I'm saying, do you know that what we have here is the same as x to the power 4 minus 8x is equal to 0. Can't I factor out x because I've got x both sides? So I'll say x open bracket x to the power 3 minus 8 is equal to 0. So get x to the power 4 to be log x everything to the power 4. So I'm just factoring out log x. Log x meaning here I'm remaining with log x to the power 3 minus here I'm going to remain with just 8 is equal to 0. That's what I've done. Is that okay? The next thing I'm going to do
Yes.
the next thing I'm going to do is just a minute, I send the link to this. Okay, the next thing I'm going to do is I'm going to say, do you understand the fact that if you have this, then you will say x is equal to 0 and x to the power 3 minus 8 is equal to 0? You know that, right? Hmm? Okay, if you don't know that, that's how it's supposed to be. So here I'll say log x is equal to 0. Again, I'll get what is in the brackets, which is log x to the power 3 minus 8 is equal to 0, like that. Let's first deal with the first part. So the first part, guys, here, which is log x is equal to 0. If log, you have got log and they have not indicated the base, is always in base 10. Okay? So you change this from log to exponential. So changing this from exponential, we say the base raised to the power what is outside is equal to what is inside. What does it mean? 10 raised to the power 0 is equal to x. Any number to the power 0 is 1. X is equal to 1. I have one value of x. Is that okay? I'm done with that part. The next thing here is I can't do anything here. I have to let. I'm going to say let y to be equal to log x. Meaning where there is log x, let's replace it with y. So I'll say y, but this y is to the power, log x is to the power 3. So I'll put it to the power 3 minus 8 is equal to 0. So for y to the power 3 is equal to 8. The cube root of 8 is 2. So y is equal to 2, like that. This is the answer. This is not the answer for x. We want to solve for x. I'll come back and say if my y is 2, what would be the value of x? So we are saying log x is equal to y. So log x is equal to, if y is equal to 2, what will be the value? Log is always in base. If they have not indicated the base, it's always in base 10. So you say the base raised to the power what is outside is equal to what is inside. What does it mean? 10 raised to the power 2 is equal to x. Okay? Therefore, x is equal to 100. These are the values of x. If I go back and plug in the values here, I'm supposed to get the same left and the right hand side. Okay? Is that cool? Is that okay? So if you find time, you plug in the values here. I can even give you here. If you put 1 here, 1 raised to the power 8 is 1. Log 1 is 0. Log 1 here, it will be 0. 0 to the power 4, 0. So this is correct. If you put 10 here, let me show you. If you put log 10 to the power 8, shift the power to be in front, which is going to be 8. So it will be 8 log 10. Log 10 base 10 is 1. So there we have 8, the left hand side. We go to the right hand side. X, where there is x, put 100. This one was 100 but to the power 2, right? So it's going to be, it's like this. X is 10 to the power 2 because 100 is 10 to the power 2. So I'll say 10 to the power 2 times 8 is going to be 16. So shift that one to be 16 log 10, which is going to be 16. If I go to the right hand side, I'll say log, I put x to be 10 to the power 2. Okay? It was 100. 10 to the power 2. Then 2 times 8 is what? Hmm? So you do this. This is going to be log base. So you shift this to be 2. 2 log 10, like that. Everything raised to the power 4. So log 2 log 10 is 2. So 2 to the power 4 is 16. So I can see that I also get 16, even here 16. If I put 1, I will get 0, 0. So that is it for the first part, unless you have questions. Okay, let's go to the next one. Solve the inequality. Solve the inequality. Our inequality here, I can just expand this. E times e, ex raised to the power 2, e times negative 3, negative 3ex, negative 2 times e, negative 2ex, negative 2 times negative 3, positive 6 less than 2e to the power x. E to the power x raised to the power 2 minus these two, they will give me 5x or 5ex. 5ex plus 6. Let's shift this to the other side. Is going to be minus 2ex less than 0. We can clearly see that this is more like a quadratic equation. To simplify this, e to the power x raised to the power 2, this guy and that guy will give me negative 7. Negative 7 e to the power x plus 6 less than 0. The best thing to do is we let, there's nothing that we can do here, so you say let y to be equal to e to the power x, meaning once you do this, meaning you replace where there's e to the power x with y. So here I'll replace with y, but it is squared, so I'll put squared minus 7 where there is e to the power x, let's replace it with y plus 6 less than 0. The product is positive 6, the sum is negative 7, the factors will be negative 6 and negative 1. Is that okay? Is that cool?
Yes, sir. Yes,
Yes.
sir.
The next thing I'm going to do is I'll just replace them. Now if the coefficient of this guy is positive 1, these are your answers. You just say y minus 6 and y minus 1, like that, less than 0. So y will be less than 6, again y will be less than 1, like that. Not so. Hmm? When you do this, guys, the next thing is these are not, we want to find the values of x. In inequality we want to find where y will replace it with x. But how do you do that? We just had to let it on top there. We said let e, remember, let e to the power x is equal to y. Now we have found that y is equal to 6. So I will replace where there is y with equal to 6. Okay? So I'll say e raised to the power x is equal to, where there is y I put 6. Let's solve for x. To solve for x here, introduce natural log. So it's going to be ln e to the power x. Even here I'll put ln 6. The properties of log allows us to shift the power to be in front. So I'll say x ln e is equal to ln 6. But what is ln e? Natural log is always in base e. Ln e of e is 1. 1 times x is x. So I'll say x is equal to ln x, ln 6. Then now where there is this guy, I'll replace with what? I'm going to say x has to be less than natural log of 6. Meaning I'm done with this part here. That is the first answer. Next thing, I'm going to replace where there is y in this gamma equation with 1. Is that cool? Hmm?
Yes, sir.
So I'll come here and say e raised to the power x is equal to y. Where there is y, let's put 1. Let's introduce ln. Natural log of e to the power x is equal to natural log of 1. What is natural log of 1? The property of log allows us to shift the power to be in front. So it will be x natural log of e is equal to natural log of 1. Natural log of 1 is 0. Okay? Same as log 1 is 0. So it will be x, natural log of e is 1. X times 1 is x, is equal to 0. Therefore, x has to be less than 0. So these are the answers. This guy and that one. Unless you have questions. I want someone to ask this question. Why is it that this type of inequality we are not going to use the table? I was expecting that question. For all type of inequalities, they will ask you to say solve the inequality expressing your answer in interval notation. or expressing or find the interval at which x is valid. That's what they do. Then at that point, that's when now you put on the table. This type of inequality, they are just saying solve the inequality. I can't put this on the table. Where am I going to find it in x? I don't use a calculator. I don't use a calculator. So you can just leave it there. But if you want, you can go ahead and use the table if you want. Because you know that ln 6 is going to be a number, which we don't know, but it's going to be a number. It's going to be positive number. Then 0, you know where to put 0. You put the table, and then you'll be able to locate where it is giving you negative. You put the answers there. Is that okay? You can use the table. You can use the table. The next question is this. You know, these guys are clever. This question, it is exactly similar question. Let me just say same question which came for 1100. For 1120. 1120, the question was find the domain 1 over the square root of x plus 4, like that. It's the same. Now 1100, they also, I think they're like, no, we have to twist it. The question is find the domain of f of g of x. Where there is x here, put the whole of that. That's what it means. So I'll say f of g of x is equal to 1 over, where there is x, we put the square root of x plus 4 minus 2. Now find the domain. To find the domain of this, you only get the part which is in the square root. Okay? You only get the part which is in the square root. In this case, you say the same thing. Okay, if I may ask, if you followed me well when we were doing 1120, how did we find the domain when we've got the square root down there? Hmm?
X plus 4 greater than or equal to 0.
That one you can only do that when you have this, and I explained the reason why you can't do that. If I have this, what you are from telling me is true. That's the sign that you are not watching the video. See, the question was find the domain. How were we finding the domain of that question we solved in 1121 over the square root of x plus 4? Find the domain.
It was x plus 4 greater than 0.
Exactly. X plus 4 greater than 0. The reason why we say it is greater than 0, initially if there was no square root down, we are supposed to get the denominator to say is not equal to 0. Again, if we didn't have the fraction, if we only had the square root of x plus 4, we would have said x plus 4 greater than or equal to 0, because in the square root we can only have 0 to all the way to positive infinity. But in this case, it is on the denominator. That's why we are going to say x plus 4 is greater than 0. So for x. So this is what we call the combination of rational and radical. So you say x plus 4 greater than 0. So for x will be greater than negative 4. And for sure here, if I plug in any number greater than 4, it's going to be defined. That's very true. So my domain now will be from negative 4 not included all the way to positive infinity. Or you can do this in set builder notation. You say x is such that x has to be greater than negative 4. X is a member of all real numbers. You can either represent this or that. You just choose. Is that cool? Hmm?
Yes, sir.
Okay, the next question is, we have been doing this, guys. The question which came in 1120 was f of x is equal to 1 over x squared minus 1, like that. I don't know if it was 1 or 4 or 9, but it was like that. And our graph was like this. I mean, if I can remember very well, 1 neg 1, like that. Our graph was 1, then it was coming like that. It was, the vertical asymptote is at 0, the horizontal asymptote, sorry, it was going like that. When you know how to sketch these, even before you sketch, you can know the nature of the graph which you are going to have. This is rational function. There is no exam without rational function. Graphing rational function is coming, whether you like it or not, both 1100 and 1120. The first thing, when we have been given this, the sketching, which is the rational function, you have to find what we call the asymptote. How do you find the vertical asymptote? To find the vertical asymptote, sometimes they can ask you to find the domain. The domain is the same as the vertical asymptote, only that the domain we put not equal to. Then the vertical asymptote we put equal to. So to find the vertical asymptote, we'll say the denominator equated equal to 0. So for x, negative x is equal to negative 1. Therefore, x is equal to 1. That is my asymptote, my vertical asymptote. They ask you to find the domain. You say x should not be equal to the vertical asymptote. Then it will be, the domain will be from negative infinity all the way to 1, 1 not included, union 1 all the way to positive infinity. Get me right there. The vertical asymptote, get the denominator set equal to 0. So for x, if you want to find the domain, get what is on the denominator, set it not equal to 0. So for x, then represent your domain like that. If the function is bottom heavy, the horizontal asymptote is always 0. In a case where you have been given 1 over x minus 1, on top here I've got, down here I've got x to the power 1. On top there I don't have x. Therefore, for this guy, the horizontal asymptote is 0. This is what we call the bottom heavy. In a case I have f of x is equal to x minus 1, then I've got x squared minus 9. Still, this function is bottom heavy. The horizontal asymptote is 0. But in a case where the denominator and the numerator, they are having the same degree of x, then you divide the coefficient. Here I have got x, here I've got x. So the degree of x, they are the same. Divide the coefficient. Negative 2 divided by negative 1 is going to give me 2. Your horizontal asymptote is the same as the domain, the range. To find the range, you just say y should not be equal to the horizontal asymptote. In that case, it will be 2. Then you say the range will be equal to from negative infinity all the way to 2, 2 not included, union 2 to positive infinity, like that. Any question? The question here is not asking about the domain and range, but I'm just giving you in case it comes.
So I just repeat when the bottom heavy.
If the function is bottom heavy, the horizontal asymptote is 0. What does it mean when you say the bottom heavy? If the x has got the highest degree of power, the power of x is higher than the power of x on the numerator, the horizontal asymptote is 0. That's why we say bottom heavy. Is that cool? Yes, if they are the same, then you get the coefficient, you divide them. In this case is 2. After finding this, you have to find what we call the intercept. You can't sketch this without finding the intercept. How do you find the intercept? To find the x-intercept, equate y equal to 0. So for x, in that case, I'll say 0 is equal to 6 minus 2x divided by 1 minus x, like that. So if you cross multiply, we'll have 6 minus 2x is equal to 0. I'll have negative 6, negative 2x is equal to negative x. X will be equal to 2 divided by 3. Sorry, 2 divided by 6 is 3. So I've got my x-intercept when x is 3, y is 0. Like that. I'm done. To find the y-intercept, equate x equal to 0. Solve for y. So y is equal to 6 minus 2, equate there 0, 1 minus 0, like that. Then y will be equal to 6 divided by 1, which is 6. When x is 0, y is 6, like that. I'm done. Those are my x and y intercept. Sketching is something which has to be on your fingertip. If I have my graph like this, the first thing is to put the vertical asymptote. The vertical asymptote is, are you getting me? Are you getting me?
Yes.
Okay. So the vertical asymptote is at what? 1. That's what we said. I'll put 1 here. Then I have to put a dotted line like that. The horizontal asymptote is at 2. I'll put 2 here. I'll put also a dotted line like that. The next thing we have been told is I have to put the points which we call the the intercept. The first intercept is 3, 2. Oh, sorry. 3, 0. Where can I find 3? In x3, it can be here, 0 is the same point. Have you seen what I've done? Again, before I even sketch this, honestly speaking, guys, you know that if I've got my graph here, let me use different color here. If I have got my graph, because it has to touch this point, running away again from the asymptote, I put the arrows like that. You know that this part here, this curve has to be reflected to the opposite side. But before you even reflect it, you have got the point which is 0, 6, which is already here. I'll put 6 here, which is that point. That point here, even if you don't reflect it, it will come there. It goes like that. Then I put also the arrow. That's the sketching of that rational function. Any question on sketching? Which is coming. So you need to practice more. You need to solve more questions on how to sketch rational function, because they are going to give you a different question. They're not going to give you the same thing. If you still don't understand, you can tell me. I'm going to send you a video, a short video on how to sketch these. Is that okay? There is a question which I have skipped. There is a question which I've skipped. Which is this one? Okay, it's okay. Let me just write this question. I know I'm going to have challenges. So that was question what? Let me check my paper here. The one for limit. That is C1. Okay. So C1 is saying C1 is saying find the limit as x is approaching positive infinity of 2x plus 5 divided by x squared minus 7 x plus 3. When the limit is approaching infinity, get me right there. When the limit is approaching infinity, the answer you are going to get is the same as finding the horizontal asymptote. Okay? If I ask you here, guys, what is the horizontal asymptote from the explanation I gave you?
Negative 2/7.
Muncho Samu, guys.
Yeah, it's 0.
Why is it 0?
Because
Because it's what thing?
If we are to expand this one down here,
Eh,
denominator,
okay.
then we replace with infinite, which is
No, I'm asking you. Okay, forget about that. I'm asking about the horizontal asymptote. What is bottom heavy? Yes, this function is bottom heavy. That's the reason why the horizontal asymptote is 0. So this horizontal asymptote, even when you are trying to find the horizontal asymptote, you are having challenges with the bottom heavy, the highest power of degree. If you get that function at x limit as x approaches infinity, find the answer. That is the horizontal asymptote. That's how we do it. So like the question we had, which was f of x is equal to 6 minus 2x divided by 1 minus x. If you get this as limit as x is approaching infinity of 6 minus 2x minus over 1 minus x, the answer you are going to find, that is the horizontal asymptote. Is that cool? So here I know that I'm supposed to find the answer to be 0. One thing you have to remember is that limit as x is approaching infinity of 1 over x is 0. 1 divided by infinity is 0. 1 divide, let's assume that this infinity is a big number. Let's say this is 1,000. If this is 1,000, this will be 0.0001. What is 1 divided by 1,000? 0.001. Okay, so 0.001 is close to 0. So if we get again a very big number, maybe 1 million, like that, this is going to be 0.000012345, like that. This is just close to 0. So if you divide a number by infinity, it's 0. That is the rule of infinity. Now when you want to work out with this problem, you factor out the x with the highest degree. You check the denominator. The denominator has got x to the power 2, so it's the one I'm going to follow. Limit as x is approaching infinity, I'll factor out x squared. If I factor out x squared on top, what am I going to remain with here? I'm going to remain with 2 over x, plus here I'm going to remain with 5 over x squared. Why am I saying 2 over x? If I do this times this, I'll go back to 2x. If I do that times that, I'll go back to 5. Okay? Then I divide this. I also factor out x to the power 2 on down here. If I factor out x to the power 2, I'll remain with 1 minus 7 over x plus 3 over x squared, like that. Have you seen what I've done? Have you seen what I've done? Have you seen what I've done? Okay.
Yes.
I'm going to cancel out this x squared and x squared. I'll remain with limit as x is approaching positive infinity of 2 over x plus 5 over x squared divided by 1 over 7 over x plus 3 over x squared. At this point, I can now plug in infinity. So I'll say this is equal to, when you want to plug in the value, you stop introducing infinity. So it's going to be 2 divided by infinity plus 5 over infinity squared. You divide this by 1 minus 7 over infinity plus 3 over infinity squared. So any number divided by infinity, I say this what?
Zero.
0. So meaning here 2 over infinity is 0 plus 5 over infinity squared is 0 divided by 1 minus 7 over infinity is 0, 3 over infinity squared is 0. So I'll remain with 0 over 1. 0 over 1 is 0. Therefore, limit as x is approaching infinity of that is 0. That's why I said when you know how to find the horizontal asymptote, when you're working out with limit as x is approaching infinity, it's going to be easy for you to know the answer. You understand? Agi, is that okay? Okay. So the last question for 1100 is this. The trick. Mhm.
I was having problems with infinity. Now
Okay, you're having
to
problem.
show me
Uh-huh.
this is even better.
This
Thank
is
you.
this is even better, right?
Yes.
So the basic idea behind infinite, guys, is check the denominator. You follow the denominator. The highest power of x you are going to have on the denominator, factor it out both on the numerator and the denominator. Is that cool?
Yes, sir.
Exactly. So the last question, guys, is this one. You can just mute your mic, Cecilia. So the last question is this. This question was a bit tricky, but very simple. To know whether or not the function is continuous at a certain point, these steps has to be followed. F of a has to be defined. Has to be defined. 2. Limit as x is approaching a of f of x has to exist. A limit can only exist. Now this point has got two sub points. For a limit to exist, you say limit as x is approaching a from the left side of f of x, it should be equal to limit as x is approaching a from the right side of f of x. If these two guys are the same, then the limit exists. That's one conclusion for you to know that the limit exists. If the limit exists, check, is it the same with that guy? If they're the same, then you say limit as x is approaching a in general of f of x is equal to f of a. Therefore, the function is continuous at that point. Let me repeat myself. For you to conclude that the function is continuous at a certain point, you do this. Limit f of a has to be defined. It has to make sense. 2. Limit as x is approaching a of f of x has to exist. What do we mean? It has got 2 subpoints. Limit as x is approaching a from the left side of f of x should be equal to limit as x is approaching a from the right side of f of x. Then you say this is equal to that. Therefore, the limit is therefore the function is continuous at that point. Let's solve this question. F of a. Now in this case we have been told, is it continuous at x is equal to 4? When x is equal to 4, when x is exactly equal to 4, what is the value of y? From this, come on guys, come on guys, when x is exactly equal to 4, what is the value of y? 0. I'll put 0 here. The moment I put 0, that is the answer. That is defined. Yes, it is defined. Now listen. 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 At that point, it is defined. For me to conclude that this is continuous, limit as x is approaching this guy, I'm supposed to get 0. Even this one, I'm supposed to get 0. If this one I get 0, then this one I don't get 0, it is not continuous. So 1, 2, 3, I'm supposed to get the same answer. Then I'll conclude that it is continuous at that point. I'll go to the next point. Limit as x is approaching 4 from the left side. The point here, take note here, is this. That's why I'm telling you that this question was a bit tricky. They are saying if x is not equal to 4, meaning I can't plug in 4, but first, which equation am I going to use? From the left side, I'm going to get the same equation, which is this. Okay? Because it's telling me that x is not equal to 4, but it can be less than, maybe it's 3.9999. So I'm going to get the modulus of x minus 4, like that, divided by x minus 4. But I can't plug in x to be equal to 4 direct, because the condition here is that x should not be equal to 4. But since we are saying that x is approaching 4 from the left side, meaning that we need to get a number which is bit closer to 4, not exact 4, but a bit closer to 4. I can get 3.9. Get me right there. I can't plug in 4 exactly because the condition is that x should not be equal to 4. Once I plug in 4, it's going to be undefined. Okay? So, I'm going to use a number which is less than 4, which is just closer to 4. I'll use 3.9. Get me right there. I'll use 3.9. So, I'm going to say this is going to be equal. When you are plugging in the values, you remove limits. So, it's going to be 3.9 minus 4 over 3.9 minus 4. What is 3.9 minus 4? This is the modulus. 3.9 minus 4. Guys, you can do this just using simple calculations. Yes, negative 0.1 in the modulus. Even down here, I'm going to get the same negative 0.1 like that. So the modulus of 0.1 is going to be 0.1 like that. Then negative 0.1. What is the answer here? 0.1 divided by negative 0.1. guys, 0.1 divided by negative 1. 0.1, again here down I have 0.1. It's negative 1 because of negative down here. I have to do the same thing with the limit as x approaches 4 from the right side. I'll do the same thing. I'll say limit as x is approaching 4 from the right side. I'll still use the same function, the modulus of x minus 4, then x minus 4, like that. The condition is that x should not be equal to 0. So I'll get a number just which is near 4, but it should be just greater than 4 a bit. I can get what? 4.1. So I'll use 4.1 minus 4 divided by 4.1 minus 4. Now this is in the modulus. What am I going to get on top there? 4.1 minus 4. Ella. 0.1. Down here, 0.1. 0.1 divided by 0.1, positive 1. So limit as x is approaching 4 from the left side of f of x is not equal to limit as x is approaching 4 from the right side of f of x. So this limit doesn't exist. So since this is, I'm getting negative 1, I'm getting 1, but f of 4 is this. Therefore, you say limit as x is approaching 4 of f of x is not equal to f of 4. You get my point, right? Therefore, the function is not continuous at x is equal to 4, like that. You only plug in these numbers when a number which is near to 4 when you have got a situation like this, because if I plug in direct I'm going to get undefined. But there are a lot of questions which you are going to see when you plug in x is still going to be direct. If I plug in 4 here, it's going to be undefined direct, especially the question which came in 1120. Check it out. This question was a bit tricky because the condition was telling us that x should not be equal to 4. That's why I don't want to plug in a value which is 4, because x should not be equal to 4. Once I plug in 4, it will be undefined. Is that okay? So it is not continuous at x is equal to 4. That's what we should know.